Now in this session I'm going to talk about collections in Java. So what is collections in Java? So collections in Java refers to the set or the collection of data. So the data here refers to an object. So when we want to manage a list or a collection of objects, so we need some kind of containers to hold that information, and also we need certain methods to access those containers or to retrieve the information, to read the information, or to modify the information. So collections framework defines the methods, the entities, the structures of certain classes, of such classes which can hold or manage the collection of objects. In Java, there are two important collections out there. One is the collection itself is one type of collection interfaces, and the other is map. Here, as you see in the diagram, so collection and map are two different things, and so a collection, again, collections are of two different types: list and set. We have two different type of collections: list and set. So what? And again, a list contains of two different types: array list and linked list. Sets are again two different types: hash set and tree set, as the diagram itself depicts. Now maps are again two types: hash map and tree map. Alright, now what is this list and set? What is the difference between list and set? What is the difference between list and set? List contains a list of objects. It can be identical objects also can reside. So that means there can be duplicates exist. There can be duplicates exist in a list, whatever it may be, whatever the list it may be. It may be an array list or it may be a linked list, but that list can contain a duplication of objects. Same object can exist in multiple times for multiple times. But set is different. A set, whatever the set it is, hash set or tree set, it can contain only it holds a unique object. That means all the objects uh, in the set, in any set, are unique. So no, so that means if you add two different same object for twice in a set, it will not be represented two times. It will be represented only once. So now, what is the difference between array list, linked list, and what is the difference between hash set and tree set? We can see. So how a list handles the data within a list is based on that there are two different type of lists are available. One is array list and linked list. In array list, the data is ordered sequentially. So if you see here, so it is like an array. So how array contains the holds the information? It holds the information in sequential order, actually in sequential manner, right? In the same way, array list holds the objects in sequential manner. So here, if you see, an array list of size 4 is there. So each so the elements in this array list here represents a literal information, but here 2, 3, 11, 7. But it normally holds, array list normally holds information objects, information of type objects. So that means employees, customers, right? That sort of information will be available. So now will be stored by array list or linked list. So now see, now how is it actually? How can I if I want an element of index 4 in this list? I can simply go, so because there have been contiguous memory allocations have been happened. So if I know the size of each of them, I can directly go to this particular location if I want to retrieve what is there in index 3. So if I know the size of first and second, based on the indexes of the memory allocations, I can calculate the index of I can calculate the memory location of index 3 easily and can jump onto that element. That means traversal is easy. So reading the information from array list is quite easy. That means when I know when I want to go to the next element, I just have to the next element is immediately allocated in the next memory allocation. So I will easily be able to jump onto those elements. In that way, traversal is easy in array list. But insertions and removals are little tougher in array list. Let's see how it is. Let's assume I want to insert a new element in the second index. that is now instead of 3 I want element 5 to be inserted here. Then what should be done for 3? 3 should not be overwritten. For that, what should I do? So I should move 3 to 11th position, 11th to 7th position, 7 to the last. That means from here 7 will be moved to the next position, 11 will be moved to the 7th position, and 3 will be moved to 11th position. So that the new element 5 will be inserted in the second position. So that means insertion from is for inserting an element, I need to adjust the indexes of the next two elements. Now earlier 11 was in the index of 3, but here the index of 11 became 4. In the same way, index of 7 uh, has changed from 4 to 5. So these indexes of the last elements have to be adjusted when I want to insert. In the same way, if I want to now in this position again, if I want to remove 3, what should I do? So if I want to remove number 3, which I want to be there, so what I should do? I should change the position of 11 should be moved to 3 and 7 should be moved to 11 position. So that only that 3 will be removed without any gap. So that means again the indexes I have to update for all the elements towards the right side actually. So all the elements should be, during insertion it has to move towards right, and during removal it has to move towards left. Why should I do so? This is going to make the insertions or removals little slower in terms of performance in the array list. Here you have only a list of just 4 elements, but in real time if you have 100 elements over here and you want to insert in the third position or fourth position, then all the elements, if we want to insert in third position, all the elements from third to 100th position all have to shift one place towards right. And if you want to remove one element in the beginning, again all the elements from last to that position have to shift one position left towards left side. So that is the overhead in usage of array list. Now let's see what is linked list. So linked list also holds a list of information or objects, so but it holds links to the next element, unlike in array list. In array list, the information is stored in contiguous memory locations, so it is easy to traverse, but it is very complex, or it is not easy to the system to perform the insertions and removals, because it has to shift the positions of the elements. But in case of array list, so the elements are not stored in contiguous memory locations. They can be stored anywhere. But how can the list will be connected is through links. So now assume we have 4 elements are there in this linked list. So each element contains the link. This part of this box, this smaller box contains the link to its next element. So it is link means it contains the address of the next element. In the same way, second contains the address of the third position, and third contains the address of the fourth position. So this is how they are connected. So this address is we are calling as link. That's why this became as a linked list. So linked list is contains every element in the linked list except the first and except the last element contains the address of the next element. So in that case, so traversal. So let's see how actually a linked list works actually. Traversal. If I have to traverse, if I have to go to the third element, I can't directly go to third element. I have to go to first element and find out the address of second. Then because the third element's address is only available in second element. So in order to go to second element, I have to I don't know the address of second element. I have to start from first element. I have to take the address of second element, then go to second element, and then read the address of third element and go to third element. That is how traversal is little slower in a linked list. Traversal or jumping onto a particular element is slower in linked list. But in case of insertions and removals in array list, in linked list is quite easy. How? Because we don't have to shift the elements. They are loosely coupled. They are just holding the links. So how you want to in a linked chain, if you want to remove a single link, you don't have to do entire thing. So you just have to remove a link and connect the two things. In the same way, let's assume now we don't want to remove, we want to remove the number 2 and no element in the number in the second position. In that case, what I should do is I just have to, so 1 is so far is connected to 2, so we just have to delink that and directly connect it to the third element. The third element address can be found in second element. Just take this link and just connect here. So that now number 2 has been delinked. Now 1 and 3 are connected. Now I don't have to shift, second. If I have to shift, if I have to remove 2, I don't have to shift 3 to second and 4 to third position. I don't have to do. In the same way, if I have to insert a new element here between 1 and 2, if I have to insert a new element, I just have to update the link in number 1 to the new element, and address, whatever the address that it 1 contains should be updated to the new element, so that they are connected. We don't have to shift the elements again towards the right side, unlike in array list. So that is how linked lists are good in terms of insertions and removals, but they are not good for traversal. That means iterating through the elements. But array lists are good in traversing, but they are not good for insertions and removal. Now let's see. So that's all about the theoretical concept of array list and linked list. Now let's see how array list and linked list can be used in Java. So to find out all the elements in array list or linked list or any collection, we have an interface called iterator or iterator. So the word iteration stands for repetition. So that means if you want to do certain operation repetitively for number of times, you need to have to iterate that. So here, why do we need iterate? When the read operations can be done through, have to be done for multiple times. And how many times? The number of the number of elements that the list contains. Those many times it has to be iterated. So all those elements. So for reading an array list or a linked list or a collection, what you need, those operations have been encapsulated using an interface called iterator, and this iterator or iterator can be obtained from a collection interface. So let's see actually what an interface contains. Iterator contains. So an iterator contains two important functions called hasNext and next. The signature of next is object. So this is very important. So when we say next, we will get the next element in that collection, and the signature of the return type of hasNext is boolean. So hasNext returns value true when there is a next element available. If there is no element, so that means when it reaches the end of that list, then it returns false. So now let's see what a collection contains. So a collection interface contains, these are the methods it contains. So mainly this contains a method iterator which returns an iterator object. That means if you want to use, or if you want to get the next element, or if you want to check whether any other hasNext element is available, we need to call iterator method first, so that we would get the iterator. So on this iterator object, we will loop through and get the next elements till it has next element. So we will see that in programmatically. So otherwise we have add. Other than these methods, the other important methods that we have is add and remove. Add takes an object what we want to add. So if you want to add an object to a list or a array list or a linked list, you just have to invoke this method. If you want to remove an object, you just have to invoke this remove. So whatever we have talked about array list and linked list, about insertions and removal, all those things will be taken care by these add and remove methods. Developer don't have to worry about how the add and how the remove will be happen in terms of in the case of array list or linked list, because this interface, collection interface, will be implemented by array list class and the linked list class, and they contain the appropriate implementations for adding a new element or for removing an existing element for the appropriate class structures. Right, now let's see programmatically how it works. So I have now, in order to explain this, we have a class called customer which contains fewer properties. So this is the object we are going to store in our linked list or in our array list. So these objects will be stored by in a customer DAO class. This customer DAO class has two methods: retrieve customers and fetch customers. Retrieve customers returns an array list. So what this array list contains? This array list contains, it's a customer summary. It contains the objects, six customer objects have been added to customer summary here. Generally, this information will be retrieve customers will be fetched from database. Since we don't want to make it complex, we just have added all those informations hard coded in this class itself. The DO stands for data access object. So this normally deals with database, but here we just have hard coded all that information within the class itself, and we just added, as I said earlier. So add is a method that we have add object. If you pass add object and pass object, then that will be added to the collection to which we invoke the add method. So here we invoke the add method on a collection called customer summary. What kind of collection is it? It is of type array list. So array list customer. Now we have seen the usage of add on the array list here. Now let's see how do I read this information. So we have a test class called array list tester. So in order to traverse through any array list or linked list, we need an iterator object, as earlier I told. So now let's see here what we are doing here. We are just instantiating customer DAO and invoking retrieve customers method. The retrieve customers method returns array list. So what are we doing here? We are typecasting that to an array list, customer list. Now what are we doing here? So in order, now our objective is to go through each of those objects and print the corresponding customer information. So how will I do that now? So in order to go through each of the object means I have to repeat that process for all the objects that are existing in that particular list. That is why this is called as iterative process. So that means I need to get an iterator on my collection object. What is my collection object here? Customer list. So how will I get the customer iterator or the iterator on an array, on a collection? By calling the method iterator. So this gives me an iterator. So this iterator is the initialization of my for loop, and there is what should I check for it? I should check for has next. So when I have to, how many times I have to perform this iteration, that should go to my condition of the for loop. The condition is till it has an element. How will I find whether the next element is available or not? By using the method has next. So has next will give returns true as long as it has a next element. Now I don't need to do any increments over here. That's why the last step of the last section of the for loop is empty. So now let's see how will I get the object of from a iterator by using the next method. So that's why we called iterator.next. But and what is this? Why should I do this? Why should I do? Because iterator.next returns an object of type object. But what do we have in iterator? If we have in iterator customer list, so that means it is a customer object. So we should explicitly typecast to customer. Now I have this iterator.next returns me the next customer object, so which I have typecasted to customer type class, and now I use the getter methods of the customer to print the values of it. So it should print me all the values of the customer. Now let's see if I want. We have, these are the methods that we have seen. We have seen in the usage of has next and next in the iterator, and also we have seen the usage of add in the collection, and also that's all. So now if I want to get an element in any particular index, so we have a method called get. Don't we have it here? Okay, so there is no get in collection, but we do have that collection interface. It might not be there. but that method is available in the ArrayList class itself. Let's see what it is. So get is a method available in the ArrayList class itself. So we don't have to worry about it. So get will return get of index. So returns. So they can returns the object in that particular index. So that is what we did here. Now let's run and see what this returns actually. So when I run this, here you see the application and the output. So we have the customer details printed here and first name, last name. So whatever we have here, so that has been printed for the first object. Again, so at the end of it, what I did, I have printed a new line. So a new line came. So two new lines comes because by default system outprint plan returns prints one new line, inside of it another new line. So two new lines have been printed. Again, so and next again another iteration. So once this iteration has been completed, the loop goes and the condition will be checked whether iterator has next element available. Yes, it has next element, so it becomes true. So it goes inside and gets the next object and prints that information as well. So like that, it prints till the end of it. Now at the end, we are showing the details of the sixth customer. So that has also been shown over here. So that is how actually ArrayList test works. Now let's see what is the linked list test contains. So how linked list can be used. So linked list is also, as I said earlier, linked list is also a collection. So this is also linked list also implements collection interface. So the operations should work same as sales. So in linked list tester, so we are invoking a method called fetch customer DAO. So what it is returning? It is returning linked list. So here we are doing the same what we have did in uh, retrieve customers. We are instantiating the objects and at the end we are adding all those objects to the linked list customer summary, and we are at the end we are returning this. So the caller of this will get uh, will get a linked list. So here when I say fetch customers, so I'm getting so when I fetch it, so in a for loop I'm just to get I need an iterator, so I just got the iterator and I'm using has next in the for loop and just fetching all the objects by using the next method and printing those information. And let's see how it works. It should work as is. It should work same. Right. So that is how actually we use collections in Java.